Okay, this is the video walkthrough for the answers to the 2019 AS Physics Paper 1. And as it says at the top, you should leave 25 minutes for this section. And I say leave because I've been encouraging you to do the multiple choice questions last, just in case you run out of time, and then you can run through at the end and just put C for all your answers or something like that. So we'll see if this video can be done in less than 25 minutes. We'll see how we go. Okay, question number 1. You have to pick the correct unit. Strain and pascals may or may not be correct. Both of those things are a little bit less used quantities than the others, so we'll make our way to the rest of the list and see what we know instead. Charge is measured in coulombs, so there's a nice freebie to start off with. We think that that is the correct answer. Power, just checking, is joules per second, and force constant is newtons per centimetre or per metre. So we know these two aren't correct. We're a little bit vague on this one. In fact, it's not correct, and this one definitely is, so we're going to go with that, and answer is B. Okay, question number 2. Which is the least accurate value? So accuracy is all about closeness to the true value. The true value for G is 9.8, so we need the answer that is furthest from 9.8, and that is that one there. So our answer is A. Question 3. Which part of the slab, A, B, C or D, is under maximum compression? So this slab used to be a nice flat shape, and now it's been loaded, perhaps under its own weight or perhaps by putting something on it, and this slab has changed shape, and you can see that the bottom side here has got lots and lots longer, and so this area, C and D, are under extension, and so they're not under compression. But the bit on the top has been squashed down together. These ends have come together a little bit, and all the particles along the top row will have been squashed together. They've been compressed on the top, so your answer is A or B. And then B is undergoing the greatest change in shape, and so this is where the greatest compression is going to be. So our answer here is B. Okay, turning over the page. Question 4. Okay, so check your axes first. This is force against time. So you should already be thinking things like momentum, impulse, formulas like delta P equals F delta T. As soon as you see the T there and the F there, you should be in this zone. Momentum, impulse, this formula. Okay, which statement is not correct? The area under the graph is equal to the work done. Well, the area under the graph is the x-axis times the y-axis, which is this, which is the impulse. So the area under the graph is not the work done. That would be a graph of F against x, because work done is equal to F delta x. Okay, so it's not the first one. The ball has maximum... Sorry, it is the first one, because that's the one that's not correct. So if we look at the others, these should all be correct. So maximum acceleration at this time, well, that time is maximum force, F equals ma. Maximum force means maximum acceleration, so that one's correct. Area under the graph is equal to impulse, that's what we just said here, so that's correct. And the area under the graph has units equal to kilograms meters per second. So we've just done force, which from F equals ma is kilograms times meters per second to the minus 2. And then we've multiplied by time, which does give us this minus 1 here. So again, that's correct as well. So we're really just doing a bit of a check. As soon as we've seen that first one at the top, we know that that's the false answer. Okay, number 5. There are two forces, and it's telling us that it's a couple. And so we might start thinking about multiplying the force by the distance to get the total moment, but that's not actually what the question wants us to do here. So make sure you read the question properly and don't get carried away. So what they want is the work done, which we know is force times distance, and it's 1 complete revolution. So the distance here is 1 complete revolution all the way around, which is pi times the diameter. And then that will give us the work done by one of the forces, but in fact there are two forces, both of them are 0.12 newtons, so we've actually got 2 of those because there are 2 forces. So our answer is going to be 2 times 0.12 times pi times the diameter, which is 8.2 times 10 to the minus 2. So if we just stick that in the calculator, hopefully one of the answers on the page will come out. And so our answer's coming out here at D. If you can have a look at the page, that's 6 times 10 to the minus 2. So our answer is D. Okay, number 6. Okay, which of these can be used to monitor the variation of light intensity in a room? So we're looking for the one that's got the LDR, and the symbol is a resistor with light coming into it. So our answer is going to be C. This one's going to measure temperature. This one's not measuring anything at all. It's an LED, it's producing light. And this one's a variable resistor, which if you attached it to a moving part could perhaps measure linear or rotational motion, but not light intensity. So our answer is C. Question number 7. Okay, we're going to swap 60 watt bulbs for 12 watt bulbs. So immediately you should be thinking that we're saving 48 watts for every single bulb. There are 10 bulbs, so we're going to be saving 10 lots of that. Each bulb is going to be used for 2,000 hours, so we need to multiply that by 2,000. And then the cost is 1 kilowatt hour is 15.4 pence. So remember, a kilowatt hour is kilowatts times hours. So if we divide that by 1,000, we'll turn it into kilowatts. It was watts at the moment, now it's kilowatts. And if we then multiply by the 15.4p, we'll get kilowatts times hour, kilowatts times hours times the price. So if we stick that into the calculator, 48 times 10 times 2,000 times 15.4 divided by 1,000. Okay, so that's in pence. So if we divide that by another 100 to turn it into pounds, we get £147.84 pence. So our answer is C. Okay, last one. So on this page, so a force of 12 newtons at an object moves an object at an angle theta, and it goes 9.6 meters. So there's our 12 newtons, and there's our 9.6 meters, and there's our angle theta, and it says the work done is 52 joules. So the work done is force in the direction of the distance multiplied by the distance. So the force in the direction of the distance will be 12 cos theta. If we resolve this force round to the direction that it's travelling in, then we multiply by the 9.6 meters, and that's equal to the work done, which is 52. So to get theta out of that, we need to rearrange the equation, and that'll give us cos theta, so we just need cos to the minus 1 of that. So when you do this, just check that your calculator is in degrees before you start, otherwise you're going to get the wrong answer. So cos to the minus 1 of 52 over 12 times 9.6, and our answer is 63 degrees, which is answer C. If you accidentally use cos instead of sine, you'll get the answer 27. So just be careful about that you get the right trigonometry. Cos to close, remember. If you're swinging this vector through this angle as if it's a doorway and you're closing the door, cos to close. If you're swinging it this way, you'd use sine. Okay, oh, and just bear in mind, it's never going to be D, because if the force is at right angles to the distance, you can't move it in that direction, can it? So it's just as long as you never put C. D. Okay, next one, question number 9. Okay, this is the first question of the ones I marked that loads of you got wrong. So you just need to be a bit careful here. The resistance of the wire is 3 ohms when it's of length L, but then the wire is stretched out so that it's 1.5 L. So lots of you just thought, well, it's resistance per meter, it's got 1.5 times longer, so the resistance got 1.5 times bigger, and you put C, but that is not the right answer. Also, you should be able to guess that it's not going to stay the same by making it longer, because the electrons have got further to go, more collisions are possible, so it's not going to be that one. And it's not going to get less resistance when you make it longer, so it shouldn't be that one. So the answer is actually D, but the question is, why is it not C? Why is it D? So hopefully if you did get it wrong, you put C and not A or B, but why is it D? Not so many of you got that right. So you need to remember that the formula for resistance is rho L over A. So yes, the length has gone up by 1.5, that's true. The resistivity is all about the material, that stayed the same, but what about the area? Well, it tells us that the volume remains constant. So if the thing has got longer, it must have got thinner at the same time. So we remember that the volume is equal to the length over the area, and therefore rearranging that, the area is equal to the volume over the length. And so this formula, rho L over A, is actually that, which gives us rho L squared over V. So the V stayed the same, rho stayed the same, but it's actually gone up by 1.5 squared, not 1.5. So 1.5 squared gives us this here when we do that. Okay, so the answer is actually D there. That's the trickiest one so far. Okay, question 10. So when you see a lot of information like this, you should start transferring it onto the diagram so you don't have to read it twice. So the minimum resistance of the variable resistor is 0, so it goes from 0, and its maximum resistance is 3R, and R is the resistance of the supply. So I don't need to read that again now. The power supply has an EMF of 4 volts, that's already on the diagram, and negligible internal resistance, it's not there, I'm just going to ignore it. And the voltmeter has infinite resistance, that just means that we don't have to worry about any parallel formula arrangement here to work out what the true resistance of this little bit between the dots is. So don't need to worry about any of that now. The resistance of the variable resistor is changed from minimum to maximum, so it goes from 0 to 3R. How does the voltmeter reading change? Okay, well initially, when the variable resistor was on 0 resistance, then if it has 0 resistance, then no work will be done by the electrons traveling through it, and no energy will be lost, and so the voltmeter will be reading 0. So it's not C or D, because it has to start on 0 volts. And then what does it go up to? Well, remember, each resistor gets its share of the potential difference. So when this is 3R, and this is R, the total resistance is 4R, and this is 3R of it, so it's going to get 3/4, 3 out of 4, 3/4 of the PD. So 3/4 of 4 is 3, and so it's going to be that one, and our answer is B. Notice that if you'd done it the other way around, the other quarter is 1 volt. So again, just have your wits about you, because the examiner is giving you the most likely incorrect answer as an option as well. Biggest resistor takes the biggest share, so when that's up at 3R, we would expect it to be getting a bigger share, more than half, more than 2 volts. Okay, let's get on to the next page. Okay, waves from the sources X and Y are coherent, and they have a wavelength of 10 centimeters. The waves are in phase here, and then constructive interference at Z, which means they're in phase at Z as well. So what does that mean? That means that the path difference is a whole number of wavelengths. So what we're looking at here is that the distance XZ and the distance YZ, they must differ by a whole number of wavelengths, and the wavelength is 10 centimeters. So what we're looking for here is for this distance to be different from this distance by multiples of 10. So 10, 20, 30, 40. So what we're looking here is that's 15, that's 20, that looks good. That's 15, and that's 35. So 10, 20, 30, 40, that's what we were looking for, and that's that one there. Our answer is B. Okay, this one. Refractive indices, which has the smallest critical angle? So this is where you need to remember that sine of the critical angle is 1 over n, and we would like the angle to be as small as possible, and therefore we need sine c to be as small as possible. And if you remember your graph for the sine function, there's your theta and there's your sine theta. So if you want a small theta, you need a small sine theta. So a small sine theta will be given to you for a small 1 over n, which means a large n. So you want the largest n here, and that's that one. The bigger n is, the smaller sine c will be, so the smaller c will be. So your answer is A. Okay, 13. So there's a frictional force that's acting on something moving through water, and it tells us that that is proportional to the speed squared. So we'll just write that down, that the force is proportional to the speed squared. And then we're talking about P, the rate at which work's done. So that's power, right? And I know that that's equal to F times V. Work done against the frictional force and the speed of the object. So the power, P, is F times V, and F is proportional to V squared, so I've got power is proportional to V cubed. The V squared here times the V here. So that's answer D there. Okay, question 14. Okay, so we've got electrons accelerating through this potential difference. Remember, that's joules per coulomb. And the electron beam is coulombs per second for the amps. And what's the energy transferred in that many hours? So it's joules per coulomb. Don't forget the kilovolts. Multiplied by the coulombs per second. Don't forget the micro. Multiplied by the number of seconds. So that's 2 hours times 60 minutes in an hour times 60 seconds in a minute. So one more time, that's joules per coulomb multiplied by coulombs per second. So that's joules per second, and then multiplied by the number of seconds in the 2 hours. So if you tap that out on the calculator, hopefully it will come out as one of those answers. And there we go, answer D, 6,900. Okay. Question 15. The electric charge on particles is quantized in a multiple of elementary charge. Which charge is possible? Well, they've all got the 10 to the minus 19s in them, so that's good, because the elementary charge is 1.6 times 10 to the minus 19. So all you want to know really is which one of these numbers divides 1.6 exactly. So obviously not that one. 4 divided by 1.6 is 2.5, so that's not right. 8 divided by 1.6 is 5, so there's our answer, and that one will be 5.5. So our answer is C. Okay. What we got now? Okay, question 16. Just keeping an eye on the time. We've had about 18 minutes, something like that, so we're going all right. Okay, so two forces, we're going to add them together. So you remember when you vector sum, you draw one of them, and then wherever you finish, start there, wherever you finish, you draw the next one, which is down there, and then that's where we finish. And so the combined vector is going to be from start to finish, which looks a bit like that. So I don't know from this picture if it's truly vertical, but there is an answer here that looks a lot like that one. It's definitely not B or C, because both of these are going upwards, and this is a horizontal force and this is a downwards force, so there's an overall downwardsness to it. So it's definitely not the upwards B or the upwards C. And when I'm comparing this one or this one, which one of these is most like my little sketch? And clearly it's A. So that's our answer there. Okay, 17. Power has this as base unit. What are intensity? So we remember that intensity is power divided by area, power per meter squared. So we need to take this and divide it by the meter squared, which gets rid of that bit there. So we're looking for kilograms second to the minus 3, and that's answer A. So it's on our list. Okay, last 3 questions. Okay, there's a ball of diameter that, held above the ground. The bottom of the ball is that far above the ground. The ball's released. Air resistance can be ignored. How long does it take to hit the ground? So we need one of our equations of motion. We've got a distance. We've got we're looking for a time. And we know that it starts from rest. So I guess we use this one, which doesn't involve us knowing the final velocity because it's not mentioned and we don't know what it is. So it starts from rest, so we can ignore that bit. And so if we want the time, so if we just rearrange that to t equals what? 2s over a square rooted. And then we put the numbers into that, so the square root of 2 times 10.2, and then just remember the equations of motion are assuming the distance is in meters, and that's in centimeters, so we better divide that by 100 to turn it into meters, and then the acceleration is 9.81. So hopefully that's one of those on the list. We've got 2 times 10.2 divided by 100, 9.81, and our answers come out of 0.144, which is there, B. Okay, question 19. Which of the following can be polarized and has a wavelength of a couple of centimeters? So longitudinal waves can't be polarized, and sound is a longitudinal wave, so we can get rid of C. And then we just need to know which one of these 3 is around about a few centimeters, and that's a memory thing, but just remember your microwave oven is, 20-30 centimeters across, and that's because microwaves are of the size of centimeters. The box we put them in is about the size of centimeters as well. So our answer is A. That's just a memory thing, but hopefully you didn't put C. And the final question, stationary waves are produced in the air inside a tube. The tube is closed at one end. Which pattern is correct? So at the open end, it needs to be an antinode. So that gets rid of B and D. And at the closed end, it needs to be a node, which is that one. So our answer is C. Okay, so what's the time? That's, what, 25 minutes? So you can see that you don't have a lot of time to hang around to do this. You just need to motor on through. Go with your gut if necessary. If you have guessed anything, stick a big star on it, something like that, and then you can go back now. So for instance, right now there's a few minutes before the 25 minutes are up. So if I'd wanted to, I could go back and check any of those. But really, you do have to keep going at quite a pace to get through these multiple choice questions, which is why one more time, do it at the end, because that's when you're going to be feeling the time pressure, and that's where you're going to naturally keep to pace. If you do it at the beginning, you can easily lose time here, and it just isn't worth more than 25-30 minutes to get these 20 marks. It's just not worth it. You'll score many more marks in the rest of the paper in the same amount of time, and so you've got to do the rest of the paper first so that you score the other 50 marks in this paper in the appropriate amount of time. You can always guess the last 5 questions of the multi-choice if you need to, if you run out of time. Okay, I'll put another video together in order to do the rest of the paper. I'll post them both to Classroom.